the next thing that we have today is types of transformer. So we have transformer in two types. One of them being called as step up, and the other one being called as step down. So either your transformer would be step up transformer, or it will be step down transformer. Okay, so for the first one, step up transformer. So this one simply means a transformer which increases the input voltage, which transforms the input voltage to a greater value. For the step down transformer, we write the opposite thing. If I draw the diagram for these two, step up transformer and for the step down transformer. So step up transformer would have more turns on the secondary coil. So let's say here we have 1, 2, 3, 4, and on this secondary side there would be more number of turns. So 1, 2, 3, 4, 5, 6, 7, right? So this is the primary voltage side, this is the secondary voltage side. These are the number of turns on primary, these are the number of turns on secondary. So what you see is the number of turns on the secondary coil are greater than the number of turns on the primary side. This is what happens in the step up transformer. Okay, for the step down, so 1, 2, 3, 4, 5, let's say 5 here on the primary. In step down transformer, there would be less number of turns or fewer number of turns on the secondary side. So 1, 2, 3, for example. So this would be Vs, this would be NP, this would be NS. So just by looking at the number of turns, they ask you in paper 1, they give you some of the diagrams and they ask you which one is the step up transformer. So step up transformer would be the transformer whose secondary coil has more number of turns. So in this one, NS is less than NP. So you can figure out from here that the more the number of turns, the more would be the voltage on that side. So if you have more turns on secondary, there would be more voltage on secondary coil, and vice versa. We have to write in terms of current as well, and for the current it would be exactly the opposite. So if NS greater than NP, then voltage on secondary coil would be greater than the voltage of primary, but then current on the secondary coil would be less than the current on the primary coil. Likewise for this one, Vs less than Vp, but at the same time for current it would be exactly the opposite. Now how do we, what do we make of this thing? We studied previously that transformer in our syllabus will be taking the transformer as an ideal device. Input power equals the output power. So power input equals power output. So whatever the input power is, the output power would exactly be the same. So let us say the input power is 100 watts, and you know in electricity we use the expression for power, P equals V times I. So if you want to measure the primary power, it would be primary voltage times primary current, and for the output power it would be secondary voltage times the secondary current. So let's say the power was 100 watts. Okay, so let me just extend the line. So the power was 100 watts, and we can assume a value of voltage. Let's say the value of voltage on the primary is 50 volts. So this is the data that we have. Power is 100 watts, voltage is 50 volts. So 50 here is in the place of voltage, and what do we multiply 50 with so that the answer would be 100? It is 2. So that means the current would be 2 ampere. Only then you can have a power of 100 watts. Now the thing is, the output power would also be 100 watts, and let's say we were having a step up transformer, and we increase the voltage. Let's assume we increase the voltage from 50 to 100. Now the thing is, since the power has to be constant, so you have to multiply 100 with a number, with such a number that the product would still be 100, and that number is 1. Now if you compare your voltage from 50 is being increased to 100, but at the same time your current is being decreased from 2 to 1. So your voltage is being increased 2 times, but at the same time your current is being decreased 2 times. Only then the power can be constant. If you're increasing both of them, let's say you say no, the current is not 1 ampere, the current is 2 amperes. Now the thing is, what would be the power? It would be 200 watts. Now how is this possible that the input power was 100 and the output power is 200? It's not an amplifier. It cannot increase the amplitude of the signal. It cannot increase the power. It is just a transformer. It transforms the voltage, but the total power of the system remains constant. So the current would be 1. If you increase the voltage further, the amount of current would be reduced accordingly. One of them is Vs over Vp equals Ns over Np equals Ip over Is. Now the thing is, you can break down this formula into different parts. For example, you can put these two things equal to each other, or you can put these two equal to each other depending on the data that you have, or you can put the first one equal to the last one. Vs times Is equals Vp times Ip. Alright, we used it already. Then the other one, Vs over Vp equals Ns over Np, and you can also write it as Ns over Np equals IP over IS. Or even Vs over Vp equals IP over IS, which would then once again be the same thing. Now where do we use the step-up transformer? So we use step-up transformer at power stations. Alright, so this is we use the step-up transformer mostly to prevent the line losses. Line losses means the power loss during the transmission of electricity. We use a step-down transformer, that stands for pole mounted transformer. You use it there. Also, step-down transformers are used in electronic appliances, chargers and stuff like that. Like I said, the electronic appliances in your house, they mostly operate on a small voltage, probably like 12 volts at maximum. For example, laptop would operate at 12 volts. Your smartphone battery would be getting like 5 volts or something like that. So you have to lower this voltage from your household socket, which is 230. You have to lower it down to 12 volts, and only then you feed it to the electronic appliance.